Hello Internet, welcome back to our SignalR in Unity series. This is part 3, so if you missed the first two, we're going to quickly go over what we've done so far. The goal of this is to kind of integrate SignalR into Unity and sort of build something from that. This is intended as just a test to see if this works, and then we can build something more advanced from this. Right now we're just trying to send strings between a console app, Unity, and in this video, we're going to be building a website that we can actually send strings from. So the idea is I have two things running here and my Unity project running. So right now we just have new text here. And then inside of this, we have our console app on the left-hand side and then our SignalR server on the right. The server isn't going to print anything, but the way this works is we can just type things. So we can say, I guess, hello world, why not? So there we go. We type hello world and that sends the message off. This thing is just an input. So we don't actually have anything to output anything. So that output that we're seeing, the name updated, is actually coming from a server update that's sending a message back to us. And that message also got sent to Unity. So when we type into that console, it automatically sends a message up to a server, which then goes and updates Unity. I'm running this all locally, but this doesn't have to happen locally. This can happen across potentially the world. So you can have the intention here is that you could have your game running and then potentially have multiple people joining over, say, mobile phones, linking into that game and kind of controlling that game through their phones or through some other means. You could also have multiple Unity clients connecting to one another and communicating that way. And that's sort of how this works. This is not intended as sort of a multiplayer replacement. It's not going to do real-time multiplayer necessarily in the same way that you might expect a normal multiplayer thing to work. But if you're looking for a way to kind of send messages whenever an update happens in sort of a client-server fashion, this gives us a way to do that. So my thought is that this would be cool for, let's say, a party game where you have a game playing on your TV and a bunch of people that are going to join over their phones. They can pull up a web app, join your game, and then start sending messages to the game, and the game can update and synchronize everything that way. So that's sort of what we're going to try to emulate here. We're going to try to build a website. We're going to do that really simply. We're going to use Blazor for that, which is a Web Assembly, in this case, C# version of writing web apps. So what Blazor lets you do is compile C# into something that's compatible with your browser. So you can just run C# apps in a browser like you would JavaScript or TypeScript or whatever else you might be developing web apps with. And so it kind of lets you take all of your C# stuff and bring it there. So we're gonna use that for this just because I like it. So that's sort of where we are. I've already built it and added the dependency. The dependency is here. It's the exact same one we're using for our console app. I've just copied it. And so if we want to run that, let's get rid of all that because that's from a separate thing and just run it. So .NET run is going to start our server for us. And so once this builds, we should have just a website. The default website has a few things going on in it. We can ignore almost all of it. So if we go here and just run this, this is our sample app. So we have 3 pages here with like a counter that we can click and increment a counter. This is going to go and fetch some data from an API. And then this is just a landing page. None of this matters. We're going to basically be rewriting this homepage because that's all we care about. Again, this is only intended as a way to kind of prove out this concept and see if it works. We're not making it pretty. We're not doing anything. We're just kind of testing things out and trying to see, does this work? And then if the answer is yes, we can come back and make everything pretty and kind of build a game around this once we know it works. It doesn't make a lot of sense for us to build the entire game assuming that it's going to work and then finding out that it doesn't actually do what we thought. So that's sort of the intention here. We're kind of capstoning this by adding hopefully an input field and a button to send the message, and that's it. So I do have notes for this because I think we're going to run into issues. So we're going to kind of get started here, and then I will fill you in. I'm going to introduce Blazor just quickly because potentially if you're coming from a Unity background, this might be new to you. Blazor lets you build web apps in C#. It uses Razor pages, which I've done some videos on in the past, but these are sort of a combination of HTML and sort of markup with C#, so you can actually embed code directly into those. And so what this ends up looking like is if we go into our pages, that ends up looking like, say, let's look at our homepage. So here is our homepage. This is a really bad example because there's no C# code. Let's look at our counter. This is probably a better example. And so that counter that we had, we could click a button. If we go back here, click on our counter, we have the counter, we have a current count and a button that we can click. And so what's happening here is we have our counter, we have the current count, and then we have the button we can click. And what that's doing is the button is calling this increment count function, which is defined below, incrementing the current counter, and then that's data bound to this current count. So what that means is that whenever current count gets updated, it actually detects that and updates the UI for us to keep both of those in sync. And so that's how all of this is working. And we can use this to kind of send our message for us. So we're going to, I guess we could just kind of hijack this counter. This is probably the closest to what we actually want anyway. So maybe it makes sense to just kind of stay here. So what I'm going to do is add an input. And we're going to add a binding here equal to something. Let's call this our name, I guess. Don't really know what I'm doing, but we'll try that. So again, haven't done this, but the way this works, we're going to bind to something that's named in our code. So in this case, I need to match this binding with the name. I don't have notes on how to use inputs, so this might not work, but we're going to try. And so let's redo this. I don't know why .NET Run doesn't get saved in my history, but anyway, if I rerun this, nothing is really going to change. We should just see an input box. If I refresh this, there you go. So now we have an input box that we can type things into. And theoretically, that test is now synchronized with that variable that we wrote, which means that I should hopefully be able to go here. And let's swap out this current count that we're using right now with a name. So instead of binding it to the current count that's going to increment, as we type into this input field, we can update that name. And so let's go and refresh this again. I could use like hot reloading or something to do this, but I'm skipping that for some reason. Anyway, we can rerun this. Let's do that. And now if I start typing, we can do test, and then it updates as soon as I hit enter or deselect this text box. It's not going to update every single time. So as soon as I click off, it updates that. So now we have something that's kind of bound there. So we can update that. So now we want to actually send this across. And so this should hopefully end up being very similar to what we've already done. So we shouldn't need to do too much, I don't think, to make this work. But this is why I took notes. Because, yeah. So we're going to jump into... Actually, I think we can just rely on what we did for Unity here. So we have a private hub connection. Let's just grab that. This doesn't have an import, so we're going to need to grab that. So that's imported from here. And I believe the way to do this is at using with the thing you want to import. So ats are sort of your escape to get out of the HTML markup that we're using. So you'll see those all over with like the at bindings, the at usings, and so on. So that's what's going on there. And then we can create this hub connection now that should hopefully have all of the stuff connected. And then if I go into here, I think we can grab all of this stuff to initially connect our server. The one thing I want to do is make sure this is in a special function. So when you're initializing a web server, it loads it line by line. We want to, once everything on the web page is loaded, we want to go back and initialize our SignalR connection. So what we're going to do that is throw this into a protected override async task that's on initialized async. So this is called after this page is initialized. We're going to run this stuff and just do whatever we said to do. So in this case, we're going to set this up and then we're going to have a callback that we're going to set up and then start this asynchronously. I took out the await in Unity, but we can add it back in here because it's a Blazor thing, so it supports async functions without like breaking your signature or anything like that. So we should be good. And that's that. The only thing here is this isn't going to work. This way of sending things isn't actually going to be a thing we can do. So what I'm actually going to do is kind of change this. We don't actually need a callback in the first place, right? We want to send messages from this app into the client, into Unity. So we don't need to have a response for when this would be updated. So yeah, let's keep it. Why not? This way, if there's multiple clients, they'll get updated automatically if somebody else pushes it. So we're just going to bind name to name. That's a really bad way of doing that. Whoa, updated name. Let's do that instead. And that way we don't have name or conflicts. And so that should automatically update our name whenever like the console app pushes a new update. That should get us all up to date. And that I think is everything. The only other thing I want to do is down here, we want to actually send a message, which I am doing from our console app. So let's just grab what we're doing to send messages. And I think it's just this. So let's run that. Let's go into our counter. And then whenever we increment count, we can change this name quickly. We're going to change the name to our new name. So whatever we update our name to, we want to send that across. So this will be our update name. So we now need to go back and change the function that is bound to update name so it matches. We can delete the current count. We're not using that anymore. And I think we're done. That should hopefully cover everything. I think I've got it all. My notes are from a previous time that I've done this. It's not actually this project, so I don't actually know if this works. But we're gonna find out real quick. This should not work. And we're gonna talk about why once I get this restarted. But this is sort of the basics for the, can only be used on async methods. So where are we using awaits? Start async. Private async. Okay, there we go. I have an await inside of a void method that isn't marked as async. That's not okay. So that's why we're getting that error. So if I fix that, hopefully it builds correctly this time. Awesome. Cool. All right, so our website should be back up. If I go and reload this. Let's try this in a few different ways. First, let's try to update this. So if I go hi and send hi, nothing happens. And the reason nothing happens is because that's not the right button. Also not the right button. What? Okay, weird. Either way, we're gonna pull this up, and I think I was expecting to see errors, but I don't. So that's interesting. Test. Why? What? Sorry, this isn't what I expected to happen. So it's failing in a different way. And that's probably not good because I don't know how to fix this. That's interesting. So we're in our counter. We initialized it. That should all be good. Did I save this? Yeah. Okay. I'm not sure. This is different. So I was expecting this not to work because of CORS issues, which because we're trying to connect to a server that our web page is not hosted on because we're on different ports, our browser is going to prevent that from happening. This is to prevent you from like sending information to like random third-party websites or something, so like an ad or something doesn't just grab all your information and send it off to somewhere or something like that. That's what CORS is intended to do. It also means that if you have like a website that's talking to two completely different places, you need headers attached to the responses and stuff so that your browser doesn't block that. And we don't have that. So why didn't this work? And how do I fix it? So this is interesting because I don't actually know. So we didn't get any errors at all, which isn't helpful. Let's see. Default levels, okay, verbose, that's not gonna help. How do I get more information? Because so our WebSocket connected to 7047. Did I create the wrong type of SignalR site? Or Blazor site rather? Because that's connecting to a different port. I don't know. Let me go and test a few things because this is doing something different than I expected. I'm going to go and try to fix this, and I'll come back with an update once I figure out what is going on, because I don't know. So I'll be back in a bit. Okay. I have confused the heck out of myself, but it works. We don't run into the problem that I thought we were going to run into. And the issue was something entirely different. So there are two ways. I should start this because this took a bit. There are two ways to run a Blazor web server. There is a WebAssembly version that would have triggered a CORS issue because we're trying to connect to a server other than our own. And there's a Blazor Server version. And the way that works is you have a website that communicates directly with a server, and that server renders changes and sends them to the clients to update them independently, which means that there's a constant connection there. It's actually using SignalR behind the scenes. Fun little fact. So I apparently decided to use a Blazor Server thing because I don't know why. I was expecting something entirely different. I was expecting to work with WebAssembly, but we're not. So this actually makes things simpler, which is good, but it made things confusing because we were getting errors that I couldn't see. And the reason was the way this works is we have everything shown here, but then we also have things running in our backend in our server that are actually rendering those changes and sending them down. And that's where the error was occurring. And so the issue is we weren't seeing them in the browser because we weren't encountering the issues in the browser. We were encountering them in the server. This is super confusing. I totally get that. But that's why this was a problem. So that architecture just screwed me up and I wasn't expecting it. So the way I solved this is I set up a debugger. So we created this. So Visual Studio Code has a launch.json, which lets you configure launch settings. Set this up. This is a template just to quickly set that up. Pointed it at the project I wanted to run and said, run this, and added some breakpoints. Then from there, we could see the actual issues. I can actually pull out my fix here. So all of this code is actually running on a server outside of our browser. That's an important note. But the issue is this invoke async here. I didn't have that. And there are actually two issues. The thing that I set up doesn't build the project. So that was causing other issues. So we're going to quickly rebuild so that I don't get errors or it doesn't appear to work. And then we can run it here. And so what we should see is it will all run normally, hopefully. And then I can connect. I have breakpoints when we send and receive messages. So if I refresh this page now, and we get back to here, I can say, let's write a test and click this. Everything seems fine, but that's just because the name updates automatically because we deselected that text box. It's bound there. And then here we hit this. This all works fine, right? Because this is all in the server. There's no any problems there. So if I can step over this, and then we get here. Here is where I ran into issues. So we have our update name. And then we have another state changed. And why didn't it explode? Oh no. I don't know why it didn't. Why that worked. That shouldn't work. We did get an exception. Did my debugger do something weird? That's odd. Anyway, you can see we're getting exceptions here. I don't know why it didn't pause our execution though. It should have. Either way, we get an issue because we are trying to, inside of this function, we are on a separate thread. Because messages are coming in, there's a separate thread that's handling those callbacks. And so because that's happening, we want to, or UI updates can only be sent from a single main thread. In order to do that, we need this. So invoke async is actually going to go out and invoke that function asynchronously to go and run it on that main thread so that it's actually processed correctly. This is pretty typical with UI applications just in general. There's a main UI thread that's going to actually handle rendering things and doing UI updates and kind of running that flow. And then background work gets run on everything else. And so we're doing a UI update. So we need to make sure that that UI update happens on the main thread. If this syntax is a little bit weird, it's the same as this. You can just sort of imply using the method name that it's a lambda, and it just works. So that's how that works. So that's it. That's all we needed to do. I'm going to skip over the cores issues because they're hard, and you probably aren't going to run into them too often. Also, this Blazor server version, I can quickly show you how to select which one you're going to see. If you go, let's see, .NET new list, you'll get a list of all of the templates. You can add and install new ones depending on like the version of .NET, even community templates. But if we look for Blazor, wherever that is, here we go. So we have two options. We have a Blazor Server app and a Blazor Web Assembly app. And so those are just going to run slightly different. WebAssembly will actually compile the entire project into a WebAssembly thing. This is perfect for like a progressive web app where you might want to like run the entire app offline. So maybe download the app locally and either run it as like a mobile app or just as like a app that you install from your browser. Blazor Server requires communication to that server, and that server is actually going to send those updates directly to you. So apparently I chose this first one. Oops. But cool. Okay. I've used both now. If people are interested in seeing the opposite implementation, it will be slightly different, but it'll be mostly the same. I would be happy to go back and kind of show that too. It will be just a little bit different. So just keep that in mind. And with this configuration, you will run into cores issues. So if you're trying to reach out to a server that is not your direct server, that's not the same one that your website is hosted on, your browser is going to start throwing errors. The only reason we're not doing this is because that's happening behind the scenes. The browser isn't trying to communicate with another server. It's communicating with the server that sent it the web page. And then that server that sent it the web page is also communicating with our other SignalR server to kind of get these updates and then send those down. So there's really four nodes, sort of in like a horseshoe shape architecture, where you have the thing that you see, and then that talks to the server. That server communicates to the actual SignalR server that we're using to actually run our game. Basically just a message forwarder. And then the console app or Unity game sits at the other end and sends things that way. And so it kind of just follows that track. So that's how that works. Maybe a little bit complicated as far as architecture goes, but it ends up working quite nicely. So what this means is that if this is all working, we've already been getting updates. Cool. So what I should be able to do is have a running Blazors, or yeah, here we go. Let's run our app so that we actually have a thing running. So once I get this running, we should now be able to refresh this. And it's currently, our Unity host is currently showing test, but now we have this text box and I can say world of 0 and send that over. Click the button, and now we have world of 0 in Unity. And so this is a super simple application, but we're just sending a text thing from a web application all the way down the chain to Unity. So pretty cool. This is intended as like a super simple thing. We're just doing strings. SignalR automatically handles serialization for you. So if you want to do like a really complicated data type, it will just work. And that's sort of the cool thing. We'll probably be doing that next, because of what I would like to do is kind of create that party game. Once I get a design that I like worked out, that's probably what we're building next. Is something that actually turns this kind of proof of concept where we have the web app and a Unity game into something that's actually something you can play. So that's sort of where this is headed. But I think that kind of wraps it up for like this introductory testing out phase. I will link a few extra resources for learning Blazor if that's something you're interested in down below. Also, SignalR isn't just a C# library. It supports a bunch of other libraries as well. So if you're working in Java and you want to write a web server in like Spring, or if you want to maybe make something in React and TypeScript or JavaScript, you can do that too. So all of that is supported. You can just go and you do that. I use C# because we're in Unity, and this way we can do our entire stack. All of our code is all C# across the board, and that just seemed cool. So, but yeah, I think that's mostly it. So hopefully this is interesting. If you have ideas of what we could build with this, leave them in the comments. I'm probably going to start building something with this probably next month sometime. Sort of work on an idea. I have a few that are beginning, but I haven't finished anything yet. And then we'll build something, and hopefully you can all play it. So that's coming up. So if you wanna stay tuned to that and kind of catch more, consider subscribing. There's a button somewhere down there. If not, if there's something I could change, leave a comment and let me know. Other than that, thanks everyone, and I will see you in the next one. So until then, see you internet.